this doing? There we go. Okay. All right. The only thing we talked about before I had to run out to that meeting last time was point. A point is a location in space. It's just how we describe any place that we want to talk about. We have our notes out, and we do not want to get behind. Please. There are two different ways, but always a capital letter. And then we touched on a line goes forever in both directions. So this was the first way I showed you how we can name a line. There's another way, but you guys don't really learn cursive anymore in elementary school. So sometimes in geometry when I have to show you that we name things in cursive, it can be confusing. So another way that we can name a line is just like this, with a cursive letter. So if you see that, just know they're just talking about the line. So we can use a cursive letter at the end or any 2 points on the line. Okay, new word of the day. First new word of the day. Collinear points. The word line is right there in collinear. Anyone want to guess what collinear points might mean? Collinear. Any ideas? Astrid. Yeah, points on the same line, to be specific. So any points on the same line. So if I'm looking at this line over here, all of these points are collinear. All of them. They're all on the same line. So I could say points A, B, C, D. They're all on the same line. Alright, line segment is just part of a line that has two determined endpoints. It's okay? Okay. Alright, line segment, parts of a line. And we just land that with any two of those points. So A, B, C, D, and I didn't mean to put that little dot there. And then ray. What do we think the definition of ray is? What do you think, bud?
A continuous line that
Goes what?
goes in a direction.
Yeah, so a line that goes in one direction. So part of a line where one end is infinite. One end. Just one. So here's the thing. When we're doing array, we have to list always the endpoint first. So the symbol for array makes sense. It's just that it goes forever in one direction, but the endpoint has to go first. So AB. But our brain wants to read from left to right. So when I look at this next example, how do I have to name this next one? Astrid. That's right. The next one would have to be FG, because we have to name it by the end. We have to tell somewhere where does it start, and then it goes on forever in one direction. Yeah, bud?
Does it matter which way you write the arrow?
Arrow's always going to point to the right. Always. Yep. Good question. All right, opposite rays. So I'll go down here for opposite rays. They have a common endpoint, and they extend in opposite. If I abbreviate anything and you don't know what it means, please ask. So ENPT is how I abbreviate endpoint. Common endpoints extend in opposite directions. So what does that look like? Opposite rays over here would be MW and MB. So their common endpoint right there, M, and then go in opposite directions. Opposite rays. So, do they form a line? Opposite rays? Yeah, they make a line. Someone just wanted to call it something else. Okay, a plane. I am standing on a plane. There's a plane above my head. All the walls are planes. A plane's just a flat surface. That's all it is. We think of planes in geometry as infinite. So anytime I'm talking about a flat surface, I call it a plane. Interesting, right? We do the same thing when we're talking about a plane as we did when we're talking about a line. Just a flat surface. I can simply say plane M, capital letter, or any 3 points make a plane. So 2 points make a line. Any 3 points will make a plane. So I don't know what points exist on this one because they just named it with that capital letter. But right here I have a rectangular prism. How many planes does it take to make this rectangular prism? 6. So let's talk about just one of them. Let's talk about the ceiling, the top. I'll highlight only the top. And I can call that plane TQR. I need 3 points on the plane to name it. So if someone knows what I'm talking about. I could name it plane STQ. That's the same plane. I could say QRS. Any 3 points on the plane, I can name it by that. So we know what just when we're naming it by one letter, that distinguishes it from it being a point. So points are always capital letters, but if I'm using just one letter to name a plane or a line, then it's cursive so that we're not saying it's just 1 point. Because we could never name a plane by just 1 point. Okay? Yeah, bud. Yeah. Okay, coplanar points. So if collinear is on the same line, coplanar is on the same plane. So let's look at this bottom one right here. Coplanar points down here, points on the same plane. So I can look at the floor here, and let's see. I'm going to do it to this paper. What's happening? What's happening here on the bottom is I have a plane, and then I have a line going through that plane. That's it. So what is the only point on this picture that is not coplanar to the others? H. All the other points are on the same plane. So the only one that's not is H. So I could name points D, E, F, and G are all coplanar. Alright, so here's your challenge to think about. Lots of words today, I know. If a line intersects a plane, what would the point of intersection be? I already said it. It would intersect at just up here, that's right, E here, but what is E? A point. So if a line intersects a plane, then it intersects at exactly 1 point, that's it. So, challenge. If a plane intersects a plane, what would be where they intersect? A line. A line. Because planes are infinite, even when we use them to draw specific shapes, we always think that planes are infinite. So 2 planes intersect in a line, and we could call this intersection SR. If I wanted to talk about where these two intersect. Okay, let's get into the fun stuff. Alright, here's a page of with scoring column numbers that I cannot Sorry about that. I just picked it up and then I realized what I had done. Okay. Postulates and theorems. So a postulate is something that we assume to be true. And this is going to blow your mind, especially this super easy one I'm going to show you. But it's assumed to be true, but it's never been proven. So in geometry, we get into proof soon, and we have to prove something. A postulate is assumed to be true because we've never found a counterexample, but we have not yet proven it either. And that's weird to try to think about. But when we get into proofs, you'll see sometimes there's just no way to get to that final part where you can say this is absolutely true. So the very first one I'm going to show you, and you don't have to write these words, I'll draw the picture for you, is called the segment addition postulate. And when I show this to you, you're going to say, why has that never been proven? That's so easy. If we have a segment AC with a point B on it, the segment addition postulate says AB plus BC equals AC. That's never been proven. We assume that it's true. Isn't that crazy? That's an assumption we make. Right? When we get into proofs, you'll see. It takes a lot of steps to prove something. We assume it's true. It makes brain sense. It makes math sense. Add, get the whole. Part equals whole. It makes sense, but we just haven't proven it with our logical skills. So, but then the other side of that, a theorem is something that has been proven over and over and over. And the most famous one that you guys know is called what? Right. I write Pythagorean like that and theorem like this. You can do whatever you want. If you want to spell it out, go ahead. Pythagorean theorem. A squared plus B squared equals C squared. We're going to use that in a little bit. Alright, distance. In geometry, often you will, what's that doing? You'll be asked to find the distance between 2 points. Essentially, when you're finding the distance between 2 points, you're figuring out how long something is. How long is this segment? What do these marks mean that I just put on here? Congruent, that's exactly right. So FA is congruent to AN. I just told you that. I can write this in 2 different ways. I can say FA equals AN, and that means their lengths are the same. Excuse me. Or I can say FA is congruent to AN. And I'm going to write this and you're going to be like, okay. And that means the segments are the same. Is there a difference there? Congruent means everything about them is the same. Just because the length is the same doesn't mean everything about them is the same. Congruent means they exist in the same space. They might be the same width. All the things about them are the same. Okay? All right. Quickly. AB. How long is AB? What's the length of AB? 10. Good job. Oh, gosh. Here it comes. Trying. BD. What's BD? Oh, my gosh. Geniuses. AE? 40. Oh. Now we're getting out of numbers. Which point is the midpoint of BE? C. Oh, this is going to be a good recording. CF. D. And that's your first little challenge today. Create a point H so that E is the midpoint. Go. Tell me where it would have to live. Got it? H. Raise your hand if you can tell me where H lives. What's the number? 70. Perfect. Good job. 70. All right. Sometimes I just write these without saying anything, so hopefully you're watching. If you see, I've already checked this in my other classes. So they had this like a week ago, so I'm trying to get you guys caught up. So there's your first 3 homeworks. 2, 3, 4. And then let's get moving. Page 3. Okay, we're going to use these now. So find these in the middle, find a marker, find an eraser. Okay. When we get done with this, I might let people go ahead and do it now. Okay, everybody has a marker and eraser, right? Hey, I can talk. Okay. Here's the thing. Oftentimes in math, you're given a formula, and everyone thinks, yay, I know the formula, I can use the formula. Great. But what if you don't have the formula, and you've forgotten the formula? If you know where it comes from, you never need it. So instead of just relying on the formula, we're going to see where the formula comes from, so you don't actually need it if you forget it. Okay? The first one you see on 3 is the midpoint formula. At the end, I will write up what the midpoint formula is. But first, we're going to do number 1 on our boards here. So go ahead and plot A and B on your board. Oh, I did the wrong one. And after you plot your point, write your number, your coordinate point numbers right beside it so that you have that and you don't have to keep going back and forth from your paper. All right, we good? Okay, to the best of your ability, draw a line from A to B. Woo, okay. Mine's kind of straight. Got it? Okay, we're going to guesstimate now. Where do we think the middle of this line is? So I think it's right there.
Yeah, because that's 6.
I think it's right there. If this line were straight on the coordinate plane and not slanted, it'd be very easy to just count how long it is, but it's not a straight line. So how do we figure out if this is correct? I'm saying that I think the midpoint, which I'll name M, is at 1, 4. What does midpoint mean? Middle. So if I added x and x and divided by 2, that would be the middle, right? So if I do my x values, -5 plus 7, and divide that by 2, what am I going to get? 2 divided by 2. Hey, there we go. Whoa. And then if I do my y value, 5 plus 3 divided by 2, what do I get? 4.
We're so smart.
We're so smart. Hey, that's the formula. You just figured it out. Formula. Midpoint is always x1 plus x2 divided by 2, y1 plus y2 divided by 2. But because we just saw it visually, it helps us not forget it. All right. We're going to skip 2. I'm going to make 2 one of your homeworks. No, actually we're not. I'm going to make 3 your homework because every time I do fractions, people are like, no! So we got to get better at those. So 3 is a homework one. We're going to do 2 together. Let's do 2. So erase. Erase. Let's do 2. -2, -8. And if you turn it vertically this time, you'll have more space like this instead of horizontally. If you turn it vertically, I still don't think we'll be able to go to 12, but we're going to do our best. -2, -8. Can we make it? All right, awesome. I'm very excited about that. And then -3, -12. Very close. That one's way down there, isn't it? Draw my line. Alright, so I did that one because that one's not quite as easy, right? I can't just find a point like we did in our first one and say, I think it's 1, 4, and then prove that I'm right. This one is not very evident where the midpoint would be. It's not going to be perfectly on a coordinate point. So let's see. If I do, what happens if I say -2 plus -3? Do I have to do that? What does that mean? Right, the total number of negatives there is -5, or I can say -2 minus 3, because this doesn't change anything, right? So -5 halves. That's my x value. Leave it as that. Leave it as that. We really want to change things sometimes, especially when we see mixed numbers in math. That's an elementary skill. As we get older, we can leave it like that. What was -5 divided by 2? -2.5, right? So that helps us visualize exactly where it would be. If I turn that into a mixed number, that's going to be a little harder for people to visualize. And then -8 minus 12 more? -20 divided by 2? -10. There's my midpoint. There's my midpoint. So it would be in the middle somewhere, -2.5. About right there. Boom. Alright, erasing? Are we good? We're going to use this again in just a second. Pop back over to notes. And I'm going to show you how to make these easy. Okay, this one, reverse thinking. There's a very easy way to do these. A lot of kids want to use the formula, plug in all the things, but let me show you. Always draw a picture in geometry. Always, always, always. If I don't have a picture, I'm going to draw it. Given a point and a midpoint, find the other endpoint. So as soon as I see that, I know I have a point, a midpoint, and another endpoint. A is my first endpoint. M is what they're calling the midpoint, and they want me to find this other endpoint B. They don't know where it's located. So I could go plot and figure this out. I could. Or I could simply say A is at 3, 4. M is at -5, -10. And we're trying to find where B is. So what? Color. To get from 3 to 5, -5, I'm sorry, I'm going down 8, right? So to get to the other endpoint, I need to go the same distance. So -5 to here, I need to go down 8. So -13. My y value, I'm going to do the same thing. To get from 4 to -10, what am I doing? Subtracting 14. So that means they went down 14 on the coordinate plane to get to the midpoint. So to get to the other endpoint, I have to travel that exact same distance. So -14 more. There we go. There's my other endpoint. No formula needed. Just using common math. See if you can do number 4 and 5, and I'll write the answer up in just a second. I'll put that back up in case you're still looking at it. Sorry. You got it? Caleb, what'd you get for 4? Good job. That's right, for number 4. Anyone got number 5 yet? Okay, hold on one sec. I think you're the only one. Let's give everyone a second. Alright, we got 5? Alright, I got -19, and what else, Mia? Good job, that's it. Okay, number 6 will be on your quiz. I'm telling you right now. Yes. Do you have the answer to number 6? Is that what you're telling me? What? You what? Oh yeah, that's fine. Yeah. Don't give everyone the answer for the quiz question, but yes. So you got it. So figure out number 6. You don't have to do it right now. I would study that one for homework. I'm just giving you a heads up. That one will be on your quiz. You did. Okay, guys. We're going to do this last little part, and then I'm going to give you a break before we finish up for the day. Distance formula. The first formula you learned was midpoint. So given any line segment, I can tell you exactly where the middle is using a graph or by the formula, right? Distance formula is very easy to understand if you understand where it comes from. So again, I'm not going to tell you what the formula is until after I show you where it comes from. So you need your boards. We're going to do number 7 on our board. So I'm going to plot 7 quickly. Please meet me there. -4, 3. That is K. -1, -2. That's L. And the question in our notes asked me to find the length of this, or the distance from K to L. That means the same thing. So if I see find KL, that means find the length of KL. If I see find the distance from K to L, that's the same thing, okay? So, watch. Here's this slanted line. How in the world could I figure out how long it is? The whole reason the Pythagorean theorem was discovered was to find distance. Can I find it? 3 squared plus 5 squared equals C squared. 9 plus 25 equals C squared. 34 equals C squared. What is the inverse of squaring a number? Square rooting a number. Square root of 34, about 5.83. So then I can pop over here, and I can say KL equals, well, actually I'm going to say about, because it's a decimal, 5.83. Well, that's fun. We're going to do 9 the same way. So erase your triangle. Let's do 9. Number 9. We're skipping 8. We're going to do number 9 together. You'll need to turn it vertically probably. 310. A is at 310. And B is at 9.2. There we go. You think you know what to do? Hey, watch. Stop drawing and watch. Ready? This is 6. This is 8. That means this is 10. 1, 2, 3, 4, 5, 6, 7, 8. It's okay. Well, how did I know that so quickly? I can do the Pythagorean theorem. 6 squared plus 8 squared.
64 plus 36 is 100.
Right. So I end up getting the square root of 100, which is 10. But this is also a very special case called a Pythagorean triple. And a Pythagorean triple is any time we have all whole numbers that satisfy the Pythagorean theorem. 3, 4, 5 is another one. So the minute that I drew this and I saw 6, 8, I just know my Pythagorean triples. I knew it was 10. I didn't even have to do the math. You don't have to have those memorized now, but anytime we get whole numbers, it's a Pythagorean triple. Okay? So I saw 6, 8, and thank God it wasn't 7. Saw 6, 8, and then it was 10. Yes.
When we gonna finish the math?
I'm going to make a plan for that. I'm not worried about it right now. All right. Just in case, though, let's write it out. 6 squared plus 8 squared equals c squared. 36 plus 64 equals c squared. We're proving it. This is how we're proving it's true. 100 equals c squared. Then I would square root both sides. I'm going to ask you guys a question right now, and you're going to tell me the wrong answer, and you're going to want to fight me. You're going to be like, this is the right answer. And I'm going to tell you that it's not. What's the square root of 100? No. What's the square root of 100?
67.
No. Square root of 100.
Square root?
Uh-huh.
Oh.
Plus or minus 10. But hey,
It's still right.
it's not completely right.
But it only
Could distance ever be negative? No, so we know it's the 10 right there. All right. Here's your formula. Your formula is going to make sense now because you know where it comes from. The distance formula is the opposite of the Pythagorean theorem. The last thing that we did right here is we took the square root, right? So this is the square root of x2 minus x1 squared. That's my a squared. That is asking how far did we move on the x. So from x to x, I went 6 units. A squared. Plus y2 minus y1 squared. So square root of a squared plus b squared. That's all it is. I prefer to write it like this, and if you want to do it like this, you can. If this makes sense to you, if you've learned it this way, great. If you haven't, today's your lucky day. I don't want all this. I want to say the change in x squared plus the change in y squared. In math, we use a triangle to represent change. If I'm figuring out the change in something, I'm figuring out how long it is on the coordinate plane. So I like to write it like this. x2s and x1s, sometimes that confuses kids. It just means there's 2 x values. That's all it means. Doesn't matter which direction I did this in if I use the formula. It does not, because at the end of the day I'm going to square it. So it doesn't matter. So if I were to say on this one, -1 minus -4, which is -1 plus 4, which is, or if I said -4 minus -1, we're going to get the same thing and we're going to square it. Doesn't matter. Okay, we did 9. 8 is yours. 10 is yours. This is your challenge right now, but you also have a little bit of a break. So I'm going to stop this video up here for the